Good morning, students. Hope you are all doing fine. In today's class, I will be explaining another important and unique characteristics of C++ language called inline functions. In our last class, we learned about what are default arguments, how we can specify default values for functional argument, and what are their advantages. In C++, what happens is you when you call a function, generally the compiler checks for the number of argument that you use while calling a function with the number of argument you specify in the prototype. In addition to that one, it also checks whether the data type of the arguments you are giving while calling a function matches with the data type that you have mentioned in the prototype. If there is a one-to-one matching, then the execution will continue. But in some situations, what happens is in the prototype, you have mentioned some three arguments. While calling a function, you might have given less number of argument. Instead of three arguments, you have called the function with only two arguments. Generally, in C language, in such situation, you will get error message because the number of argument you use it while calling a function should exactly matches with the number of argument you have mentioned in the prototype. But in C++, one flexibility is there. Whenever while calling a function, if some arguments are missing mean, then for such missing argument, it will take the value from the default list, the default value you are giving while writing the prototype of the function. And we also already studied what are the advantages of using default argument, etc. in our last class. In today's class, we will be learning about another unique characteristics of C++ function called inline function. In which situation we can use inline function and what are the rules it is imposed while using or while making a function as inline, and what are the advantages and disadvantages of inline function. So these are the three main objectives of today's class. After attending today's class, at the end of today's class, you will be in a position to understand why we can make the function as inline function, and when or in which situation we can make the function inline, what are the rules for making the function inline, and what are the advantages and disadvantages of making a function inline. In order to understand what are inline function, let us recap what are functions. We know that functions are nothing but subprogram that perform some specified task. Every function has some specific task, so that task is achieved through the statement contained within that function. Generally, functions transform the data from one form to another form. For example, if you write a function to calculate the factorial of a given number, in that case, what happens is the function takes one number as input and gives the factorial as output. That means here the data is, suppose the data is 5 means the output is 5 means the data output will be 120. And two functions communicate with each other generally through passing of argument. In most of the cases, calling function will be the main function, the other function will be the called function. So function establish a communication between calling function and called function. The main advantages of function is it saves time and also it reduces the length of the program. The reason is by writing a function once, you can call it any number of times. So in every time you need not write the code associated with the function. Write the function only once. You can call in the calling function that corresponding called function any number of times. So every time you need not repeat the code associated with particular function. So this not only reduce the length of the program, it also saves the programmer time. So programmer can do more coding in less time. But generally, when you call a function, some changes, some arrangements or some changes will take place inside your machine. For example, if you call a function called f in the main program, in that case, what happens is when the moment you call a function, the first thing is the value of the actual argument should be saved in a special register called stack register. Then the control has to leave the calling function. The control has to leave the main function. Then the control has to jump to the called function. Then do some work in the called function. After the calculation is over in the called function, the control has to leave the called function. The control has to come back to the calling function. After coming back to the calling function, it has to go to the stack register where the values of the actual arguments are preserved before jumping into the call function. Then it has to fetch the values of all the actual arguments which are already stored in the stack register, and your execution continues with the next statement in the calling function. So all these things require results in lot of time. So all these activities require time. So that time we will call it as an overhead time, because generally when you call a function, the five major changes are: the control has to leave the calling function. Before leaving the calling function, the values of the actual argument must be preserved in the stack register. Then the control has to go to the called function, do some calculations in the called function, then leave the control at the called function, comes back to the calling function, go back to the stack register, fetch the value, and continue. So here what happens is, your calculation in the called function is very, very less. In order to do simple calculation in the called function, it involves lot of overhead time. For example, leaving the control at the calling function may take 1 unit of time. Then storing the values of the actual argument in the stack register, that may take 1 unit of time. Then the jump has to go to the called function, that may take another unit of time. And do some computation in the call function, that may take 1 unit of time, 4 units of time. Then after the computation is over, the control has to leave at the call function, that may take 1 unit of time. It has to come back to the calling function, that may take another time. And finally go back to the stack register, fetch the value, that may take another unit of time. So all this what happens here, your computation within the call function is simply a 1 unit of time. But for doing 1 unit of computation in the call function, you are investing or you are wasting lot of time in leaving the control here, going there, fetching the value from the stack register, etc. So all such things take some time. So that's time we call it an overhead time. So for small function, what happens is, your overhead time is more than the computational time. In that case, it results in wastage of your time, and the computer or the compiler takes more time for execution. Then what is the alternative? How to avoid this overhead time? See, this is the how when you call a function, it happens. So here the calling function is the main function. Inside the main function, I have declared a variable called a of integer type. Then I have declared another variable called b of float type. And the prototype of the called function is, the called function name is root. It takes only one argument of which type? Integer type, and the return type is float. Next, what happens is, you are calling the function called b equal to root of a. So when you call a function called root, here the actual argument is c. So before the control goes to the root function, the value of the actual argument a is first stored in the preserved in the stack register. Then the control has to go to the root function, do some simple computation, calculating the square root and returning the value is done in the root function. After that one, it comes back to the calling function and goes to the stack register, fetch the value of a again from the stack register and display it, and display the value of a. And again, if you want, you can display the value of b also. See here, how much time is involved in calculating the square root? Only 1 unit of time. But the additional overhead time is preserving the value of a in the stack register, 1 unit. Jumping to the called function called root, another unit of time. Then calculating the square root, 1 unit of time. Coming back from the root function back to the main function, another unit of time. Going to stack register, fetch the value of a, another another unit of time. So altogether, it takes 5 units of time. Out of 5 units of time, only 1 unit of time is required for computation. Remaining 4 units of time is simply moving from here and there. So that time we call it an overhead time. So this is generally happen in any function. Whenever you call any function, these changes will take place every time. So it results in lot of wastage of overhead time. So our intention is to minimize or eliminate this overhead time. How to avoid this overhead time? Let us see. There are two approaches for eliminating the overhead time. The first one is by writing the function as a macro. In your first semester, you already studied in your C language what is a macro. Macro is nothing but a preprocessor directive. Example, hash define pi 3.14. Here what happens is pi is a macro name. The value associated with pi is 3.14. So here what happens is in your main program, in your function program, wherever you use the word called pi, what happens is the value of that variable pi 3.14 is substituted in your calling function. In your calling function, wherever you use the word called pi, automatically the value associated with that particular keyword, particular identifier pi is substituted in your program. So similarly, in the previous example, the function is root, the computation is recalculating the square root and returning the value. So that I can write it as a function, that I can write it as a macro. If you write it as a macro, what happens is whenever you call a function, automatically what happens is the control will not move from calling function to that called function. Instead of that one, if you written it as a macro, what happens is the content of that macro will be substituted wherever you call that macro. So instead of leaving the control from calling to call, after that coming back from call back to calling, you can avoid by writing it as a macro. Whenever you write something as a macro, what happens is when you call a macro, the code associated with the macro will be copied into your calling part. So by writing anything as a macro, we can avoid this overhead time. But macro has certain drawbacks. The thing is, macro is a preprocessor directive. A preprocessor directive is one which is not directly executed by the compiler. It is executed by preprocessor. Okay. So here what happens, see, if you write something as a macro, it is not directly executed by the compiler, means error checking is not possible. Even if you come across some mistake in your macro also, that is not detected by your compiler. Whereas if you write it as a function, function is directly executed by the compiler, means if you come across any error, if you make some mistakes in your function, that is naturally detected by your compiler. Whereas macro is not directly executed by the compiler. Macro is not directly processed by the compiler. Instead of that one, it is processed by preprocessor. After preprocessing, then it is passed on to compiler. So error checking is not possible if you write something as a macro instead of function. Then what is the alternative? My intention is to write it as a function because I want the error checking to be done by the compiler. At the same time, I want to avoid the overhead time. So my intention is two here. One is I want to avoid the overhead time. Second thing is I want to write it as a function itself. By writing it as a function, I want to avoid the overhead time. In the case of macro, what happens is we can avoid the overhead time, but without writing it as a function. Already explained what is the problem by writing it as a macro, because it is not, error checking is not possible for macro. What is the alternative? There is another way, or the second method of avoiding the overhead time by writing it as a function is inline function. So the purpose of an inline function is to write something as a function. But whenever you write something as a function and plus to avoid the overhead time. In the case of macro, what happens is you are avoiding the overhead time, but you are missing the opportunity of error detection by the compiler. But in the case of inline function, what happens is you are writing it as a function only, but still you are avoiding the overhead time. So you are enjoying the benefit of error detection by the compiler. At the same time, you are avoiding the overhead time also. So your both the objectives are achieved by writing it as an inline function instead of a normal function. Let us see what are inline function, how inline function can be written, what are its advantages and disadvantages. An inline function is a unique feature of C++ function, which is why it's called unique, means that feature is not available in your C language. It's an alternate way of avoiding function overhead time. The reason why it's called an inline function, if you write something as an inline function, what happens is whenever you call that function, for example, in the previous example, the calling function is the main function, the root is a called function. My intention is to, I suppose if I make the root function as a inline function, what happens is whenever you call the root function, the control will not go from main to root function. Instead of that one, the content of the root function will be copied into your calling part, will be copied into your calling function. So instead of controlling living from calling and jumping to call function, the call function only will come to your main function. So compiler replaces the function call. Wherever you call the corresponding function, the compiler replaces the corresponding place with the code associated with that corresponding function. There is example. In the previous example, you are calling root function something like this. So here I am calling the function called b equal to root of a. Here in the normal function, it has to jump here, do the calculation here, and comes back. But if you make the same function as an inline function, means the line return sqrt of a, that is the content of the function, that is automatically copied into this place. So you are not, your question of jumping from calling to call, do the work there and returning back, all these things are completely avoided. So that is the intention of making any function as inline. If you make any function as an inline, what happens then? Whenever you call that function, the code associated with that particular function will be copied wherever, in whichever point you call that function. So your problem of jumping from calling to call is avoided. Similarly, after the calculation is over, you need the jumping from call function back to calling function. That is also not there. So this overhead time is completely avoided. Because inline function, and you make some function as an inline, the code associated with the corresponding function will be copied into the place where you call it in the calling function. Let us see how the prototype of the inline function returns. The main difference between inline function and a normal function is you just add the keyword called inline before the return type. For example, in the previous example, I have written float root inside the bracket in. The reason is return type is float, function name is root, number of argument is 1, and the data type of the argument is also 1. But in the case of inline, before writing the return type as a float, before that one, you prefix the return type with the keyword called inline. If you just add the word called inline, means the function works in an inline mode, means your overhead time is avoided. Whereas the definition, how you define the function, will not change at all. In the defining function, first you write the return type, function name, argument declaration, then you write the statement one by one, then return expression. For example, if you make the previous example root function, if you want to make it as an inline function, means first in the prototype you write it as inline, return type is float, function name is root, argument is int. Then while defining the function, return type is float, function name is root, argument is a, means that is an int type, int a. The statement is return sqrt of a. That's all. So in the function, there are two concepts. One is first you have to mention the prototype, then you have to define the function. Just in the prototype, you prefix the return type with the keyword called inline, then it becomes an inline function. But what type of function I can make it as an inline, or what are the rules, that is, what are the restrictions on making the function as inline, that we have to study now. One thing is the difference between a normal function and an inline function is, in the case of normal function, a normal function can be defined either before calling the function, or you can define it after the calling function. That means in the previous example, the called function is root. If it is a normal function, means root function, you can write it either before the main function, or you can write it after the main function. But you make some function as an inline, means that should be defined first. Before calling only you have to define. That means generally inline functions are written first, then you start your main function. Normal function, you can write it either before main or after the main. Next, what type of function I can make it as an inline? So generally small function where the computation is very, very less, such function you can make it as an inline. Don't try to make a huge function as inline. If you make a huge function as an inline, what happens is you are not getting the benefit associated with the inline function. The benefit associated with the inline function is it avoids the overhead time. Hence, even if you make a big function as an inline, you will not get any error message. But still, it will not execute in inline mode. That means if you just add the keyword called inline, then what the compiler will do it, the compiler checks whether it is possible to execute the function in an inline mode. If it is possible to execute the function in an inline mode, then it will execute as an inline fashion. But if it is not possible to execute in inline mode, in that case, it will execute in a normal function mode. So that means even by writing the word keyword, it's not, you can't dictate the compiler to execute in inline mode only. You are the keyword inline is just a request for the compiler to execute in inline mode, because if you execute in inline mode means your overhead time is avoided. But if it is not possible, means it cannot execute in inline mode. That's the reason the keyword inline is simply a request. You specify the request so that if it is possible, you will avoid that overhead time. If it is not possible, nothing, you are not going to lose anything. The compiler will execute in a normal function execution. Only small function can be made as inline. Other thing is, in these three situations, even if you make the function, your inline function will not work. The one is, if your function contain any looping statement like for loop, while loop, do loop, switch statement, go to statement, if your called function has any one of these three, in that case, you can't make such functions as inline, the first one. And your inline function should not contain static variables. The last one is, inline function cannot be recursive. Recursive function, I cannot make it as an inline. Okay. If the function is recursive, you make it as an inline, in such a situation, you may get error message. But for bigger function, if you add the word called inline, then if it is possible to execute in inline mode, your execution will continue, you will get the benefit of inline. But if it's not possible, means in such situation, you will not get any error message. The compiler execute in a normal function call, a normal function mode. Now I'll write one simple example of calculating or checking whether a given number is even or odd. I told you in the beginning, inline function must be defined first, whereas then you can call the function. So first I will define the function. So return type is, say here, the function even takes one number called a. If the number is even, it returns 1. If the number is not even, it returns the value 0. So return type is either 1 or 0, means an integer type. Return type is int, even, and int of a. So argument is a, and the return type is 1 or 0. Next, if a percentage to equal to 0 means it's an even number, in that case return 1, else return 0. So 1 is return mean it's an even, given number is even. 0 is return mean the given number is odd. So this is the function definition. In the function definition, don't add the word called inline. Function definition, you start with the return type, function name, and the argument declaration. Then you write the statement one by one, then some return. Then this is how your main function looks like. Hash include iostream.h, conia.h, those things already know. Then here the function name is even, argument is int type, return type is also int type. Then the only thing you have to make it, you prefix the return type with the keyword called inline. A and b are two variable. Then enter a number, the input is a, call the function b equal to even a. So control jumps to your even function. If the given number a is an even number, then suppose a value is 14. In that case, b value becomes 1, because 14 is an even number. The function even return the value 1. If b equal to 1 means the given number is an even number, else the given number is an odd number. So return, the number is even or odd is decided by the return type. If 1 is returned by the even function, means it's an even number. If 0 is returned, means the given number is an odd number. What are the benefits of inline function? One is speed of execution is increased, because you are avoiding the overhead time. Naturally, your execution speed is high, and it avoids overhead time. These are the two main advantages of making the function as inline. But the one thing you should remember is, don't try to make a very large function as an inline, because in that case, you will not get the benefit of inline. And the drawback is, inline function, even though it gives you some advantages, it suffers from certain drawbacks also. If you make inline function, I already told you, whenever you make the function as an inline, the control will not jump from calling to call. Instead of that one, the call function only will come to the calling function. So if you call the function some 3-4 times, means what happens is, wherever you call that function, the code associated with that function will be copied into the calling point. Means internally, the number of lines in the main function, number of lines in the code in the calling function will increase. So it naturally takes more space. So if you make inline function and you're calling the function only once, means okay. But if you're calling the function many times, means then in every place, the code associated with the function should be copied. Means the main size of the main function, or the in general, the size of the calling function will be more. So it makes the program to take more space. So these are some of the review questions. Generally, in your examination, one question will be on inline function. It could be either 2 marks question or it could be some long answer question also. What are inline function? Why we need inline function? The main necessity of using a function, making the function as inline is to avoid the function overhead time. Illustrate with an example program inline function. You can give any example. In the examination also, you can give the same even function. Write the advantages and disadvantages of inline function. Let us see. Let us revise what we have studied in today's class by means of some simple multiple choice question. Inline function dash reduce the length of the program. No, it increase the length of the program. Reduce the speed of execution. That is also false. It increase the speed of the execution. Increase the speed of execution. That is true. The correct answer is C. Dash function can be made inline. Simple function where the computational time is very less when compared to overhead time. Such function can be made as an inline. The correct answer is A. The keyword inline is a command. No, you cannot dictate. It's just a request. Rule, none of these. The correct answer is B. Alternate way to inline function is recursive function, overloaded function, iterative function, and macro. Macro or the preprocessor is one alternate way of avoiding the overhead time. But it's not a function. In that case, you are losing the benefit of function, because whenever you write something as a function, the error detection is done by the compiler. But if you write something as a macro, error detection is not done by the compiler. It has to be detected by the preprocessor directly. So the correct answer is D. Inline function must be defined before they are called, can be defined anywhere, defined after they are called. None of this. General function or normal function can be defined either before or after, but inline function should be defined before you call them. Hope I have enjoyed today's session. As a summary, in today's class, I gave the necessity of making the function as inline. What type of function we can make it as an inline, or in which situation inline function will not work. What are the advantages and disadvantages of inline function? For your any queries, feedback, doubt, etc., you can call me over that number or mail me, or you can post your comment in the comment section also in the Google Classroom. Thank you.